Saving time with Oracle Clips.
This video will outline the following: why use virtualization, an overview of how virtual machines work, an overview of how containers work. So with that in mind, let's dive in. Prior to using virtualization, business applications ran on physical hardware which required large centrally located servers that multiple users could interact with. Over time, more servers often need to be added as the number of users increases. This caused the business to invest more time, pressure and expense in both the IT and end-user departments. So, as virtualization became more popular, many IT departments invested in virtual management technology such as Oracle Linux VM on the server or VirtualBox on the desktop. Virtual machines, VMs, work by emulating the hardware required to run the operating system and software. However, the users are unaware they're not actually connecting to a physical machine. However, VMs are not very portable, should the need arise to move them, that is. So when Docker burst on the scene back in 2013 and made the packaging and configuring of applications running on Linux far easier than ever before, using containers really took off. The huge benefit provided by containers is that they virtualize just the operating system environment and not the hardware as well, unlike VMs. Each container ships together with everything it needs in order to run properly once deployed. So let's look first at how virtual machines work. Well, the first thing to know is that there are two types of virtual machine software available, Type 1 and Type 2. First up, the Type 1 virtualization stack, which is usually deployed onto the central IT servers, for example, Oracle Linux VM. This comprises of the hardware, followed by the hypervisor, which is a highly specialized software responsible for emulating the hardware, such as CPU, RAM, disk, network interface cards, which then builds and runs the virtual machine deployed onto it. This virtual machine is comprised of the following: operating system, dependencies, application. Next up is the Type 2 virtualization stack. This is what you may have installed on your laptop, for example, VirtualBox. It's almost identical to Type 1, except this time the hypervisor software, for example VirtualBox, is installed on top of an operating system rather than directly onto the hardware. Now let's consider how containers differ from virtual machines. Just like virtual machines, containers require some physical hardware followed by a Linux install to utilize the functionality that Linux provides to run containers, followed by the container or containers that are to be deployed. So let's compare the requirements to run containers directly with those required for a Type 2 virtual machine. Do you notice the difference between the actual contents of a container and virtual machine shown inside the red boxes? The virtual machine packages more than a container. Why is that? Let me go into a little more detail, but not too much, I promise. First up, all operating systems consist of two layers, Layer 1 and Layer 2. Layer 1 is the operating system kernel. On Linux, if you keep it fully updated, this is often the same version, whatever distribution you are using. Layer 2, this is the application layer. Again, on Linux, this comprises what makes Oracle Linux into Oracle Linux and other variants what they are. In other words, this can be different. Microsoft Windows also has the same architecture. However, the kernel layer is not available for other vendors to package their own versions of Windows by altering what ships in the application layer. So, a virtual machine is much larger than a container because it has to package both Layer 1 and Layer 2 together with any dependencies and the application, unlike a container which requires only Layer 2 to be packaged along with the application. This difference means that containers start much faster than virtual machines because there is no need to start an underlying operating system. On the other hand, with virtual machines, it is possible to run any operating system on top of any other operating system. So, why are containers so popular these days? Well, on the plus side, their portability and ease of use of updating or scaling make them much easier for businesses to deploy and manage. However, as the deployment footprint grows, it can be harder to retain control over important aspects such as security and compliance. This is where software such as Kubernetes has become popular, as it helps to address the problems with deploying, scaling, and managing containers in large environments. I hope this overview of how a container differs from a virtual machine has helped. So many thanks for watching.
You can see more clips here, and don't forget to subscribe to always get the latest.